In this tutorial, we're going to walk you through all the options in the Moulding Toolpath, where we can easily create toolpaths for moldings that have a constant cross-section. A 3D toolpath is created without the need to create a 3D model to ultimately give us a better finish and may even reduce the machining time. To get started with this tutorial, we're going to need a new instance of our software. So we've opened that up and we're going to create a new file. Now to start off with, this is going to be a single-sided job. We're going to change the job size. The width will be 26. The height will be 6. Our material thickness is going to be 0.75. We're going to zero off our material surface. Our XY datum will be set to the bottom left-hand corner. We can leave our modeling resolution set to standard. The great thing about the Moulding Toolpath is that we are going to be using 2D vectors to create the 3D tooling, but there will be no 3D component ever created. So we don't need to worry about having any more than just the standard number of pixels to work with. Our material setting, we'll just leave it as it is, and then we're going to click OK. In order to use the Moulding Toolpath, we need a minimum of 2 vectors. We need one that we're going to use as a drive rail, and one that will define the cross-section of our molding. We're going to take that cross-section or profile vector and extrude it along the drive rail via the Moulding Toolpath strategy to give us the toolpaths that we need to cut the full molding. So to start out with, let's go ahead and create that drive rail. So we're going to go over here to our polyline tool. We're going to click that. Our first point is going to be at 1 and 1, and we can click add. And if as soon as I move into my 2D view, you'll see that I have a polyline that started at 1 and 1. And because I have my toggle smart snapping turned on here, I can snap that to a horizontal line. And because we can see the numbers below our smart cursor, we can go ahead and just run that up to be 24 inches. I can left click and then right click to get out of that form. And now what I can do is go ahead and create my profile for my molding. Now we've already pre-created that for you to save us a bit of time. So let's go ahead and import that in. So we're going to import some vectors. We can navigate over to our tutorial folder. We're going to select our molding profile number 1 and click open. Now let's have a closer look at that vector profile. So with it selected, we can just go up here and zoom to selected object. Now we've deliberately created this vector so that it's the exact size that we need. So it's 0.7 high along with 4 inches wide. And you can see that information right here in the bottom right-hand corner. And it also has some flat spots and some really sharp radiuses here. And these will help us to show you some different features of the Moulding Toolpath. Now let's just press F on the keyboard and have a look at our Toolpaths tab. So let's just jump over to there. And the first thing, as always, we should take a look at our material setup and make sure that everything here is correct. So first of all, the thickness of our material is 0.75 of an inch. Our datum is set to the lower left-hand side. We're going to zero off our material surface. And our position in our model is all the way to the top because we'll be referencing the top of our material and there isn't any 3D content in here. We're going to start right at the very top. And our rapid Z gaps and our home start position are set up so that they're safe and appropriate for our machine. And now I can go ahead and click OK. Now let's just off-click the vector that we have here, the profile. So we'll just click somewhere in our white space. And let's have a look at our Moulding Toolpath strategy. Okay, the first thing we need to do is we need to select our drive rail or rails and the cross-section that we're going to use. In this case, we only have one drive rail and we have our cross-section there. So if we go ahead and choose our drive rail and hold down our shift key and grab the cross section, you'll see right away the software will start to show us what's going to happen with those 2 vectors. First of all, on the drive rail, we'll see our start point. We'll see the direction of flow, and that's indicated by these arrows here. And then also these red vectors that are hanging off the bottom. These are exactly 4 inches long, which is the same width as our cross section. So if we chose to go with this as it is, our Moulding Toolpath would hang off the bottom of that vector. Now that's not exactly what we want. So in order to do that, we can right click on our line and we can reverse the direction of that drive rail. And as soon as we do that, you'll see our start point has switched ends and now all of the red indicators here are all proud of that line. So you can tell that it's now on the right side. Now it's important to note too that you can reverse the direction of your cross section as well. In our case, this is symmetrical, so it really doesn't matter a whole lot. But if you needed to have a certain end of your cross section hanging off of the vector that you're going to use as your drive rail, then you might need to reverse that. So we can right click on that vector and we can reverse the direction if we want to. And we can get the right end hanging off our drive rail. Now that's great. So we've got those all selected. Now let's move on to our toolpath position. Right now it's at the very top of our material, and you see there's a slight gap at the bottom. When I first went over the vector profile, I mentioned to you that we actually drew it the exact height that we wanted it to. So the bottom of that profile should be the back of our material. So let's move this down so that the light brown area of our icon here is at the back and the darker brown is at the top. So this indicates that we're going to have a part in the end that's exactly the same height as our profile with some extra material above it. And we're going to choose a gap above model. And we're going to go ahead now and choose our finishing tool. So let's select that. And we're going to use a 1/8 inch ball nose end mill. And we're going to choose select. And then we're going to turn off Vary Stepover. We're not going to worry about a large area clearance tool. We're not going to worry about sharing or creating sharp corners. We're not going to be using any kind of boundary offset. And we're just going to go ahead and calculate that. And when we do, you'll see that in our 3D view, we have the wireframe of our toolpath. And if we roll it up on its end, you'll see that the end of the wireframe preview, you can see the top of the cross section there. And so we're simply just extruding that or running our tool the distance that we want following that contour. Now, if we go ahead and take a look right at the end of this, and we zoom in a little bit, and we'll go up here to view, and we'll turn off our color shaded view. We'll zoom in a little bit more. You can see the actual movement of the tool. It's going to come in here. It's going to plunge. It's going to do its thing, move along. But you'll see that as it comes down these radiuses, there are quite a few steps here, aggressive steps that it's making. And that's based on the Stepover of our tool. And that's consistent around all of our molding. And in some places, it's going to be less obvious than others. But it could be a bit problematic and would take a lot of handwork to get rid of that. So we have a method built in that we can alleviate some of that. So let's go back and look at our isometric view. Let's go up here to view, and we're going to turn back on our color shaded view. Go back into our toolpath again, and we're going to take a look at varying the Stepover of that finished cutter. So if we click that, and I'm going to click recalculate, but you watch what happens in the 3D view. You'll see how some of those lines get closer together. And that's because as the tool is running down the radius of those, the Stepover is actually getting less to help alleviate some of that stepping that's in there. Now we can preview our visible toolpath, and you'll see that we get a nice, clean looking piece of molding. That looks great. Let's close that down and go back into the toolpath again. The next area to consider in our molding toolpath is whether we want to use a large area clearance tool. And this is akin to using a large roughing bit when you're doing a 3D toolpath, where you're going to go in with a bigger bit, remove the majority of the material, and then come back in with a smaller cutter and remove the leftover material to show off your nice detail. So we're going to say yes to that. And then we need to select our tool. So in our tool database, we're going to look at our end mills, and we're going to choose the 1/4 inch end mill. And we'll select that. We're going to ignore machine flat regions. We're going to choose to add in ramp and plunge moves, and that's going to be set to 1 inch. We're going to leave a machining allowance of 0.03 of an inch. That means we'll leave a small skim of material behind to come back in with our ball nose and clean up later. And we can just go ahead now and calculate that. Now you'll see that in our toolpath section, we have 2 toolpaths now, not just one. One of them has clear at the end, and that is your large area clearance tool. And then this is your finishing tool. So if we hide the finishing tool and we reset our preview, you'll see that with our larger end mill, we're going to come in and remove all of this material. So let's preview that. And then we're going to come back in with our finishing bit. That's the 1/8 inch ball nose. And we can go ahead and remove that material. And that looks really great in the end. Now let's close that down and take a look at one of the other options we have to look at. Now we can also choose to ask our end mill to go in and machine the flat regions. So let's turn that on. And what will happen is anywhere that this flat end mill can fit, it'll go in and ignore the machining allowance and go right down to the surface where you want it to be. So there won't be any machining allowance left behind for your ball nose to go in and remove. In that case, seeing as we have this turned on, we may as well get our ball nose to skip those flat areas because they're already cleaned up for us. And let's go ahead now and calculate that. Reset our preview. And let's have a look at our clearance toolpath. Let's preview that. And you'll see that the tool goes in and cleans up those flat areas that we saw on our profile that we imported. And then we can go in now and have a look at our finishing pass. And you'll see that it actually skips those areas because it doesn't need to go in and remove any of that allowance. So let's preview that visible toolpath. And that looks really good. And we get nice flat bottoms and no cusping at the bottom of these walls here. Let's close that down and go back into our toolpath again. Okay, the next part of our form down here is create sharp corners. And for this demonstration, we're going to ignore that right now because we have just one drive rail. It's a straight line. So it's not important for this particular demonstration right now. Now, the next thing to consider is going to be our boundary offset. So look at that. Let's go ahead and tile our views. And let's look at the end of our profile here. So right now, when we cut this, we're actually stopping at the edge of our profile, but never dropping off the side of it. So right here on the top. So the height here is the thickness out here on the side of your molding. Now, if we decide in a boundary offset, because we actually want to overshoot that a little bit, let's type in 0.2 of an inch. Now, I've chosen to type in an actual number. We could get the software to use an automatic boundary offset where it calculates it on its own. But for us right now, we're just going to go ahead and type in a nice round number, and then we'll calculate that. Okay, let's reset our preview and have a look at these toolpaths one at a time again. So let's look at our clearance toolpath first. Let's preview that visible toolpath. And you'll see right off the bat, as soon as it gets to the edge, that it's actually overshooting the end or the edge of our profile by that 0.2 of an inch and cutting through the material. And let's have a look at our finishing pass. And that goes in and nicely cleans all that up again. Now it's important to remember that the offset only affects the edges of our profile that are parallel to our drive rail. So in this case, it's the bottom and the top, not the ends of our molding. So let's go ahead now and take a look at the isometric view of this again. Let's click on our 2D view and press F on our keyboard. And then we're going to go back into our toolpath again and take a look at the rest of the options. In the last section in this form, we're going to see a reflection of our safe C and home position that we entered in our material setup. And then we have our automatic vector selectors here. Right now they are set to manual because we've chose those manually, but we can also have our software select vectors based on certain parameters for us. And we'll get to that a little bit later on in this tutorial. So let's close this down. Now, what if we wanted to actually cut this piece of molding out? Well, currently right now, this molding is exactly the same length as this line. And typically, if we were going to use our machine to cut out this piece of molding, we'd want to actually have a piece of molding that was too big and then go back in and cut out the part that we want. So let's go ahead and demonstrate that. So the first thing we're going to do is edit some of our vectors here in our 2D view. So let's bring up our vector drawing tools. And we are going to select this and we're going to go into node mode, or we can just press N on our keyboard. And we're simply going to use our cursor keys and nudge these out a little bit longer than what they should be. Okay. So let's go ahead and create a rectangle. We're going to make sure that our anchor point is set to the center. Our X and our Y start positions are going to be at 0, 0. We're going to use square corners. We're going to make our rectangle 24 inches and the height of it is going to be 4 inches. And we can click create. So to center that rectangle, we'll select it and we're going to use our align selected objects. We'll click that and we're going to use the center icon in this top selection, which is align to material center. So we can click that. I also could have, with that vector selected, press F9 on my keyboard, but it's always good to remember that all of these options are here for vector alignment. Let's close that down. And now we're going to go ahead and edit our tooling. So let's go back to our Toolpaths tab, bring up our sweep profile. We're going to recalculate that because it's a bit longer than what it was. So let's calculate that. Let's reset our preview and let's preview our toolpaths. There we have it. Let's close that down. Now, using this vector that we created, or this rectangle that we created, we're going to create a profile cut. We're going to start at 0. We're going to cut all the way through our material, which is going to be Z, and then we can just press equals. That way our software will go find that for us. We may as well use this 1/4 inch end mill. We're going to cut outside that line. We could go ahead and add ramp and plunge moves if we would like to, but I'm not going to in this demonstration. We could add tabs if you wanted to hold your piece of molding in place, but again, for this demonstration, we're just going to leave those out. And we're going to rename this cutout. And then we can calculate that and preview that visible toolpath. We can double click on this waste material, and there we have our finished piece of molding at the right length that we need it. That's great. Let's take a second and consider one more thing. When we chose our profile, or when we imported it in, I noted that we had these legs on it and this was all drawn to scale. Well, if we select this and we zoom into that selected part, don't need these legs on here. These were just here mainly in our case to visualize what the full cross section would be at the proper height. If we go in now and remove those legs, let's select that and press N on our keyboard and hover over top of this line segment and right click. We can go down to delete the span. We can do the same thing over here and we can delete that span. And then we can close this down. Let's go back into our toolpath and see what that looks like now. When you look at our toolpath position, you're going to see that we still have the 0.5 at the top, and we have now 0.1875 at the bottom. This happened to be the actual length of the leg on this. So this light brown area here is defined by the area that this profile will take in your material. Now you have the control here, if you'd like to, of moving this profile up and down, and the remainder of your material on the back would actually be your backing. So you can put this all the way to the top if you wanted to, and so you would have 0.2375 of material to make up the thickness of your molding. That's just important to know. In the end, in some cases, you may only have one leg, or one of these nodes will touch the bottom of your profile and the other side will not have a leg. And we'll see that a little bit later on, but it was good just to point that out here. So let's close this down. Let's maximize this. This would be a good time to save this off. So let's go up to File and choose Save As. And we're going to choose this file. We're going to rename. We're not going to save over top of that file. We're just going to go and rename this example _1. And we'll take that there. We'll just save that off. Let's now go ahead and create a brand new file so that we can compare the times of the traditional 3D roughing and finishing passes with this molding toolpath. And also it would be a good time to have a look at the differences in the finishes that we get. Let's start off with a new instance of our software and we'll create a brand new file. This is going to be a single-sided job. The width of this job is going to be 40 inches. The height of it is going to be 12. The thickness of our material will be 1 inch. We're going to zero off our material surface. Our datum will be set to the lower left-hand corner. Because there'll be no 3D content in here, we can leave this at a standard resolution, and we'll leave the material setting as it is, and then we'll just click OK. Now, as we know, in order to create a molding toolpath, we're going to need a drive rail and a cross section. So let's start off by drawing an arc. So let's click this, and we're going to use the through 3 points method. Our first point is going to be at 4 and 1, and our end point will be at 36 and 1, and we are going to set our height to be 6 inches. So that's fine. And let's create that, and let's close this down. Now again, for this demonstration, we're going to use a pre-created profile for us. So let's go up here and import in a vector from our tutorials folder, and we're going to choose Molding Profile 2, and we'll open that up. And you'll see it's arrived down here in our bottom left-hand corner. Let's go ahead and zoom in on that so we can take a really close look at this profile. Now, first of all, you're probably going to notice that it's missing a leg. And this will demonstrate to you that you don't need to have both legs. As long as your curve ends where you'd like it to be, the software based on your actual molding toolpath will decide how much it's going to add to this for your backing, or whether it's going to leave it flush, and it will just continue this down without any problems at all. Now again, we have engineered this profile to give us a really good example of some of the strengths of the molding toolpath. So there's some nice curves here and some flat areas here as well. So let's press F on our keyboard to fit back to screen again. And let's go ahead and tile our views and pop over to our Toolpaths tab. Now, as always, we're going to check our material setup before we start. The thickness of our material is 1. The datum set to the lower left. We're zeroing off our material surface. There's no gap above our model. We're not using any 3D content, so we're going to make sure it's all the way to the top. And our rapid Z moves and our home start position are safe and appropriate for our machine. I can click OK. Let's go into our molding toolpath, and we'll select our drive rail first, and we'll hold down our Shift key and select our profile. And like we did in the last demonstration, you can see that we're hanging our cross section off the wrong side of our drive rail. So let's right click on that and we'll reverse direction, and it will flip it to the other side for us. As with our last example, we're going to drop our toolpath position just below the surface of our material, and the gap below it will be 0.2 of an inch. So we're going to add 0.2 of an inch to the thickness of our molding profile here. So as a finishing tool, we're going to select a new tool, and we're going to choose the 1/4 inch ball nose end mill. And note the feeds and speeds down here. These will not change, because when we go and compare this toolpath to toolpaths that were created on a 3D model, we want to make sure that all of this is the same. So I'm not going to change any of this between those two examples, so we'll get comparable times. So we'll select that. We're going to vary our Stepover. We're going to skip the flat regions. We're going to use a large area clearance tool. So let's select that. And we're going to choose a 1/4 inch end mill. And again, these feeds and speeds will be set exactly the same in both examples. So we can select that. We're going to machine flat areas. We are not going to do a ramp plunge move, and we're going to leave 0.03 allowance behind. We're not going to have any boundary offset. We'll set that down to 0. And we're going to go ahead and just call that sweep profile, and then we'll calculate that. And let's turn off our finishing pass, and let's preview our roughing pass here. So that's what we expected to see. Let's turn back on our finishing pass, and let's preview that. And that's exactly what we expected to see. Now let's maximize our 3D view and have a close look at this. Now this looks like a really nice tool path, because the way our tool will actually follow along that vector arc that we have. Our finish will be really nice and clean. Any machining lines that we have will actually follow this arc, which means they may be not even noticeable, or they'll be easily sanded out to blend in really nicely. And also you can look at all these areas that are below the bottom of these curves here are nice and smooth, and there's not much cusping going on there, if any at all, because our tool is actually going to be going right along there, and the bottom of that is the radius of our tool, and that looks really nice and smooth. Now let's go have a look at the same file, but in a spire based on a 3D model. Okay, so this is a spire, and we have a component that's built using the exact same cross section that we use for the molding toolpath, and it's on the same arc that we used as well. So if we take a look at our 2D and our 3D view together, you'll see that we have a cross section, and also we have the arc that we used to create our molding toolpath with. So let's have a look at our tooling. Over here I already have 2 toolpaths already created, and like I'd mentioned, I use the same feeds and speeds from the other molding toolpath that we saw. So if we show our roughing toolpath, we can just go ahead and preview that. You see that looks like what we'd expect it to. Let's close that down, and then let's go ahead and have a look at our finishing pass. Let's preview that, and we'll see what we have. Let's maximize that and take a look at this file. Now again, it looks quite nice, except for you can see that there is a lot of cusping going along here because of the nature of a raster toolpath where it goes back and forth. The tool won't be going along that arc nice and smoothly. Now, you can go ahead and probably sand that out if you wanted to, but I suspect that you'll be taking more time to do a bit of cleanup on this version of the tooling than you would have if you had to use the Moulding Toolpath. So let's go back on that again, and let's just close down. Let's have a look at our times for these two toolpaths. Let's go ahead and bring that up. You'll see that's going to take about 2 hours and 16 minutes to cut the tooling for the 3D model. And if we go back to our other version with the Moulding Toolpath, we can close this down and let's check out our times. And you'll see that it's about 2 hours and 2 minutes. So we shaved off roughly around 16 minutes of our time. And we got a much nicer finish in the end. And I firmly believe that for this type of job, your best bet is for the Moulding Toolpath, and it will save you more time in the end than just what you see in these tooling times. Let's turn those off. Let's have a look at that again. That looks quite nice. Let's go ahead and save this off so you can have this for later if you'd like. File, save as, and let's go ahead and call this example number 2 and click save. Now there are a couple other options that we haven't looked at in the Moulding Toolpath, so let's go ahead and have a look at those now. So let's start off with a new instance of our software, and we are going to go ahead and open an existing file. If we navigate over to our tutorials folder, you're going to see a file here called Moulding Toolpaths Guide-Frame Example. So just select that and choose Open. So right away in our 2D view, you're going to see a vector profile of a frame, which is great. We're going to use that as our drive rail. We also are going to need to have a cross section. Now, before we do any of that, we should take a look at our job setup to make sure it's set up properly. So let's click there. It's a single-sided job. The width is 40, the height is 40, the thickness is 1. We're going to be zeroing off our material surface. Our datum is set to the lower left-hand corner, and our modeling resolution is set to very high. Now, because again, there's no 3D content going to be involved in this, we can drop that down and we can go back to standard. We'll leave our material set up the way it is, and we'll click OK. Now, we're going to need to find a molding profile. Now, if you've chosen to download and install the free clip art that comes along with your software, you would have received a pack of molding profiles. Let's go have a look at those. So in my clip art tab, in my clip art folder, you're going to see a folder here called Molding Profiles. If I click on that, you'll see you have a nice little selection here of molding profiles to get you started. For this demonstration though, we're going to go back to the cross section that we used in our last demonstration. So we're going to go back to our drawing tab, import in a vector profile, and we're going to use molding profile number 2. Let's open that up, and here it is down in the bottom corner. Now let's go ahead and flip over to our Toolpaths tab and check our material setup and make sure everything is fine. 1-inch material thickness, datum set to the bottom left-hand corner. We're zeroing off our material surface. There is no gap at the top of our material because we don't have any 3D content in here. We don't have to worry about that. And our rapid Z gaps and our home and start position are set safe and appropriate for our machine. And now we can click OK. Let's go have a look at our molding toolpath now. Like we know already, we need to select our drive rail and our molding profile. So let's go over into our 2D view, click on the drive rail and hold down our shift key and grab the profile. And you'll see that everything is aligned properly. We're hanging off the right side of our vector like we kind of expect. So that's all great. Let's look at our toolpath position. Again, we're going to drop it down into our material just a little bit. So that'll leave us a bit of a backing here of 0.2 of an inch. We're going to go ahead and leave this as our 1/4 inch ball nose. That's fine. We're not going to use a large area clearance tool. And now we're going to look at this option right here, which says create square corners. For now, we're going to leave it turned off. And we're just going to go ahead and calculate that. And let's preview our visible toolpath. Now you'll see that our end result has these rounded corners here, which is quite nice, but it's not exactly what I think that we expect. We like to have nice mitered corners here. So let's close this down and let's go back into our toolpath again. And we're going to tell our software to create sharp corners. And let's recalculate that. Let's reset our preview. And let's preview visible toolpaths. And you'll see now we get these nice mitered corners in the end. Let's just close that down. Look straight down our model again, and let's tile our views just for a second. Now the next thing we're going to do is go back into our toolpath here, and let's reverse the direction of our cross-section profile here. So let's right-click on that, reverse direction. Let's recalculate our toolpath. Let's reset our preview and let's preview visible toolpaths. And that looks kind of nice as well. So with that one cross section, we can get two different looking frames if we would like. Now a frame isn't really much of a frame if you've got this center point here and you've got this outside material outside of this. Let's go ahead and show you how to create the profile cuts you're going to need to cut out the center. Let's close this down. Let's off click on our 2D view and let's select our vector profile. Now you'll see down here in the bottom right hand corner, with that selected, it's 4 inches wide. We know that, and we can see that down in the bottom right-hand corner. So if we offset this vector outwards by 4 inches, then we'll have the two vectors that we need to profile this out with. Let's go back to our drawing tab again. Select the offset option. Let's choose outwards 4 inches. We're going to make sure that we create sharp corners, offset that, and close that down. Let's go back to our Toolpaths tab again. And with those two vectors selected, let's go into our profile toolpath. Let's have a start depth of 0. Our cut depth is going to equals Z, which is the thickness of our material. So if you type in Z and press equals, it'll go ahead and fetch that thickness for you. We're going to use a 1/4 inch end mill. We'll cut outside that line. We're not going to do ramp and plunge moves. We won't add any tabs for this demonstration. And we'll just rename this cutout. And we'll calculate that. Preview our visible toolpath, and we can go ahead and remove our waste material. And there we have a nice frame left over for us. And that demonstrates, again, the feature of our molding toolpath that's reflected here with create sharp corners. Okay, let's have a look at the final section of options in the molding toolpath. And for that, we're going to open up an existing file. And we're going to look for the file that's called Moulding Toolpaths Guide Vector Selector Example. So let's choose that and click Open. Now right away in our 2D view, you're going to see the two vectors that we need for a molding toolpath, or at least the minimum number we need. And that's one drive rail and one molding profile. If we have a look at our Layers tab over here, you'll see we have two different layers set up, one called Molding Rail and one called Molding Profile. If I turn off the molding rail, you'll see that the rail disappears. So that would tell you that the rail is on that layer. And if I turn off the molding profile, you'll see that it'll disappear. So that indicates that it's on that layer. Now let's flip over to our molding toolpath again. And let's bring that up. Now in this example, we're not going to do what it says in this first box. We're not going to choose the drive rail and the molding profile. And we're not going to do anything with this next box down, which is the toolpath position. We're going to continue on to tell it what the finishing tool we're going to be using is. And we'll go ahead with the 1/4 inch ball nose. And we're going to vary our Stepover. We're going to use a large area clearance tool, but we're going to select a end mill, 1/4 inch end mill. We're going to use the machine flat regions option. We're not going to use any ramp or plunge moves. We're going to leave a little bit of material behind. We're not going to create sharp corners. We're not going to use a boundary offset. What we are going to do is take a really close look at this bottom bit here, the rail selection or the automatic vector selector. So currently right now you'll see that it's set to manual. The rail selection is set to manual and the profile selection has been grayed out, but it's also set to be manual. And that's what we normally do, is we'd manually select both of those options, our rail and also our profile. But we can also ask our software to do that automatically based on some settings that we give it or some filters that we give it. So let's go ahead and look at our rail selection. So if we click on Selector, this is the normal vector selector dialog that you see in a lot of our other toolpaths. I'm not going to get too much into this right now because there are a couple really good videos that deep dive into this, and I'll link those in the related videos below. But for now, we are going to set up our selection filter, and it's going to be any open vectors that happen to sit on our molding rail, and you'll see that it's automatically picked up the one that's there already. And so we can associate that with the toolpath and we can select close. And as soon as we do that, we have the option to now automatically select the profile here if we'd like to. So let's just go ahead and select that. And we are going to choose any open vectors that happen to be on the molding profile, and you'll see that it's selected already for us. We're going to associate that with a toolpath, and then we're going to close that down. Now we can do like we already know how to do. We're going to right click on this rail and we've reversed the direction. That way it's hanging off the top of our drive rail. And we can go ahead and calculate that. And we can preview that visible toolpath. And there we have it. Let's just go ahead and reset that, and let's go back to our toolpath for a second. As soon as it automatically picked those up, then you'll notice that this area here got populated with some information. So at this point now, we can go ahead and drop that down a bit if we want to, and we can recalculate our toolpaths, reset our preview, and then we can preview our visible toolpaths. Not much has changed, except for it's dropped it down that 0.05 of an inch for us. So let's reset our preview again. Let's close this down. And let's tile our views. And let's have a look now at what we can do with those filters. So if we flip back over to our drawing tab, we're going to look at adding in another vector. We're going to make sure that it's on the molding rail. We're just going to drop one in here anywheres. And we can right click. We can go back to our Toolpaths tab again. And let's go back into our sweep profiles, and you'll see what's happened now. Because that extra rail we just added was on the proper layer, on the molding rail, it's picked that up for us. So we can instantly just go ahead and reverse that rail, recalculate that, preview our visible toolpaths, and you'll see now we have two pieces of molding. This would be an excellent example if a customer walked in on the street and they decided that originally they wanted to have a nice curved arch, but then said, well, maybe I want to see this as a straight piece of molding, or maybe as a wavy piece of molding. And because we have all of that already set up in our vector selector, then we can add as many different profiles as we'd like to onto this molding rail layer, and it will just automatically associate those and calculate those toolpaths for us. So that's great. So the next thing we can do is we can take a look at maybe changing out our molding profile. And as we know, we can only have one molding profile per toolpath or per molding toolpath. But if we go back over to our drawing tab again, and we look at our layers for a second, you'll see that we have two different layers set up, like I mentioned earlier, and we're going to select the molding profile. If we go to our clip art tab and we look in our clip art under molding profiles, and if you've chosen to download all of the free clip art content that comes with your software, this is a free little pack for you, and you get a whole bunch of different pieces of molding. So let's just double click on molding 10, and you'll see it arrives into our job space. And let's look at our layers, and you'll see that we've added a brand new layer in, and that's where this guy happens to sit. So if we right click on it, we can say move to molding profile. And because we only have one molding profile per molding toolpath, we'll need to move this one off of here. So let's click that, right click on that, and we're going to move back to layer 1. Let's go back to our toolpath tab, and we close this down. Go back into our molding toolpath. Our manual and all of this has been set back to manual again. That's because when we came into this toolpath, we had this vector selected. So if we unclick that and close this down and look back at the toolpath again, you'll see that now it's set to automatic like we had it set originally. So that's a good little thing to know. Another thing you'll notice is that our toolpath position is totally full. That happens to be because this profile is exactly 1 inch thick, which is the thickness of our material. And if we wanted to add in a gap above that, we need to scale this down a bit. But for now, we're going to leave it just as it is, and we can calculate our new toolpaths, reset our 3D preview, and then we'll preview those visible toolpaths, and you'll see that we've automatically swapped out that vector and applied it to these drive rails. And with that, that ends all of the different options that we have available for you in the molding toolpath.